class. Hopefully you are getting used to it and familiar with it. Today we're going to talk about the next part, which is the structure. We'll also use the knowledge you learn from the pointer part, so you can keep practicing them. Okay, so structure. What is structure? So previously we use variable separately, right? Like you have a variable for storing the year, right? Have a variable storing the month and the date separately. And later on, if you want to use them, you use all three of them, again, separately. It is okay for a small amount of data like this, but once we have a system, right? You have a database system, you have like a real application, you want to make sure that you always have a defined number of information. For example, the date information. Data information are used everywhere, right? Let's say you in your HR system, you want to store employees' birthday, right? Their starting day, and maybe their payday, right? Everything are stored as date, but you cannot. It will be very tedious if you store their birthday year, employment day year, payment year separately, right? It's very, very tedious. So you want to have everything related stored together. So that's the point of using structure. The essential point of having structure is to have a collection of variables. Could have the same type or different types, or pointer if you need together. To be clear, this is a static way to store information, which means when you create the variables, you have to initialize it out there. Okay, you cannot leave it open, just like in Python or Java, you using dictionary or map, you can keep adding things into it. It cannot do it. Okay, it's like just for storing information. All right, not for dynamically changing content. So the purpose is you can have all the information related coming together, right? It's easier for you to store information. It's very efficient on the memory part, but it's less flexible comparing to maps in Java. In maps in Java, you can add items into it. You can call the item inside, maybe rather than using the index, right? But those will be more complicated to store in the memory. As I mentioned, one typical use case is in the payroll system, right? You have an employee and you want to store all the information together. So here is the example. First, you want to create a structure called date. All right, inside the structure, you could have day, month, year. You can have more, including like day, year, or month name. So this gives you a kind of template where you can store everything related to date. Okay, so how you declare it? So you can have structure and date. Date is the name of your structure, and then the name of your variable d. All right, so this part you can change whatever makes sense to your case. And this is how you declare a structure. So once you declare that, you can access the member of it using this point operator. So you already have this d as a day structure, right? Then you can say d.year, right? That will give you the year. Or you have d.month name, it will give you the month name. Well, it's quite straightforward. You can have structure nested, means one structure can contain another structure. For example, in our HR system, we have this person's structure, right? This is a top-level structure. underneath you have the name, etc. Then you have their birthday, right? This birthday variable itself is a structure itself, right? So this is what I mean by nested structure. So in this case, you can see it makes sense. You have them separately because you can reuse the same structure for different purpose. Like one is for birthday, the other is for hire date. Again, you can use the point operator to access the information. For example, you have a variable called employee, which has a structure of a person, right? And then you can point birthday, it will get into this birthday variable inside. Then you point month, you get into the month variable inside this birthday structure, right? So you can keep doing that it will start from left side to right side, right? You do this operation first, then the second one operation later. Well, it makes sense. You cannot do that other way around, I see. Okay, so essentially you have two operations. One is taking the address using this @ sign, and the other is getting the member using the dot sign. Okay, we'll talk about the @ sign a little bit later. But essentially, why you need using the @ sign is use pointer, right? If we're going to assign the structure to a pointer later on, then we're going to use this operation. We will talk about that a little bit later. In the old fashion, like before 1980-ish, you cannot copy a structure just by using the equal sign. Let's say we have defined this thing, let's say this one, D variable, right? And then you cannot simply copy the content of this D by using the equal sign, say have an E equal to D, right? You cannot do that in the old days, but now you can do it. Okay. In the modern compiler, yes, you can copy the structure using a single assignment statement, which is okay. However, you need to be aware that this is called shallow copy. That means it will only copy over the value inside the structure. But if you also have the pointer inside, it will not copy whatever the value the pointer pointing at. It will copy over the pointer, but not the pointer pointing at. Oh, it seems quite complicated to call, but as well as the structure. Say if you have nested structure, you will only copy the first level of that structure content. Second level, you only have this pointer copied over to that structure, not the value inside of it. Okay, so let's take a look at example. Now, this time, we'll declare our date variable not using like a D anymore. We're using a pointer D. Okay. Anyone can tell me what's the benefits of you doing this way? Using this pointer D rather than you declare the structure date D as we showed before. What will be the benefit of doing this way? Well, essentially, what's the benefit of using pointer?
We can use the values outside of the structure.
Any data structure?
Like outside of the structure date, yeah, we can use the values.
Okay. Any other thoughts? Any other benefits?
Efficient memory usage.
Could you be more specific of how it makes memory be efficient?
So in case of pointer, they make direct access to memory. So if it would be fast to access, which can save space, like a new variable. We don't have to create a new one and then access it. So it would be the address assigned to it. So it goes directly to the address and uh, uh, for the large data like array or structure, we can direct accesses by referring it using the reference rather than copying the entire data.
All right. Yeah, thank you for the information. This is correct under the circumstances if we're calling the structure inside a function, right? So if you're passing this structure to a function and doing a bunch of operation, right? So if you passing the pointer only, that means whatever operation done in the function will happen on the variable directly, right? Rather, if you don't use pointer, you will make a copy of it, right? You make a bunch of operation, then you have to return it back to override the original value. So that's you essentially take twice as much as memory space is needed, right? You can make a copy of the entire structure. Rather, if you use a pointer, you only copy the pointer over, right? So again, that's the same idea as the array we talked about earlier in our class. Yeah, thank you for your answer here. Okay, so we know there are a few benefits. There are actually more than this I mentioned, but let's just focus on this one. Yeah, now we know the benefits of it. Let's see how we can use the pointer to access the member of it, right? Before, if it is a variable d, in that case, we will use the dot to access the member of it, like dot year, dot month. But if this is the pointer structure, we're using this dash and bigger sign, right? This is almost like an arrow symbol here. It should be quite straightforward to understand what does this mean, right? This pointer pointing at one of its member, right? And it gives you the value of it. So this is the same as this expression, right? So we have this pointer. If we're using the stars of this pointer, give us the value of this pointer pointing at. Then we use the dot member. That's essentially the same as this arrow sign, right? So this arrow symbol, just a shorthand of this way, just to make you a little bit clear to read and easier to write. Yeah, but you can do either way. All right, so previously we have talked about a function which is to convert the month, date, and year into day of year, right? Let's say if February the 2nd will be converted to day of the year will be 33, something like that, right? So we used a date table to store the number of days per month, and one row for I think this is the normal year, and the second row is for the leap year, right? So we'll determine if it's a leap year or not. Then we adding up the date of every previous month, then the last month's date to get the total day of the year. So we have done this before, but instead this time we're using structure, right? Because we want to store everything related to date, month, year together. So this is the structure we have created here. Now, if we look at our new function, day of year function, so first of all, we're passing this pointer. The pointer is pointing at our day structure, right? So this is a day structure pointer. It gives us access to the date, give us access to the year and the months, right? So we could either getting the date value by having this expression or directly using it, right? Like the PD arrow year. So this thing will give you the value of the year in our structure, and we will do a bunch of operation directly, right, one way or another. So the logic is the same as we have talked about before, so I'm going to not repeat it, but just to show you how you can use this pointer or arrow sign along with pointer to access the member inside the structure. All right, so Similarly, you can do the same for the operation to reverse the operation. So if we already have the day of the year, or you could convert it into the month and the date, we can doing this operation again using the PD and arrow to access the member of it. All right, so again, not going to explain the logic of this program because we have looked at it before at least twice already. But again, this will be how you access the member of the structure using the pointer. So here are a few operations, but you should understand this arrow sign and the dot sign has high precedence. So that means it will happen first, right? So this will be the most confusing operation you can see here. Typically, you would imagine this plus piece will happen first, right? Then you pointing at something, but actually not. This arrow operation will happen first. So you have this pointer P accessing its member X. Then you increment this member X by 1. Okay, again, this is the most confusing one because you don't give any brackets to tell you which happened first. But you should remember that this arrow dash bigger sign will happen first. So that will give you the member of this P rather than the P itself. Then we will increment that member value, X, which is the member value. All right. If you want to increment the P rather than the X, then you have to put the bracket here to force it happen, right? So we will increment this P value here, or rather we increment this pointer to point to the next location, right? Then we access the member of it. Yeah, so here this operation means we are accessing this Y first, then we getting the value of whatever the Y pointing at to. Right? So this only makes sense because the Y is also a pointer itself. You can do that. If you're pointing at X, then you cannot do that because X is not a pointer. This star symbol will happen on the member, right? Just like this plus symbol do. So now we have the basic knowledge about the structure. We wanted to look at how to use them inside the array. Right. So the structure is very useful, and we can use it to say in a case that we have a list of existing keywords. Okay, and then we want to create a program that will scan the whole input file and identify how many of those keywords has happened inside the file, right? So to do that, we will first create a structure called key, right? Well, not called key, but as a structure type as key. Inside this type, we have two values. One is the keyword itself. The other is the count of the keywords. All right. For example, this will be our keywords. Right. So the break, case, char, continue, default. Those are the keywords in the C language, right? For each of them, we initialize it with the count as 0 because we haven't scanned the document or code yet. But imagine later on, let's say we apply this, we create a function that will scan all the input file and identify every single word inside of it. And if you find it, one of those keywords, say break, you will have this increment by 1, right? So this has become very much like a dictionary-ish, right? So we can increment the counting the number of those keywords from the file. But the only problem is the structure don't allow us, or the array of structure don't allow us to directly access this value using this key, right? Although we feels like this is almost like a dictionary, but this is not. We cannot do that. So instead, what we're going to do is we have to create a search function to search where the key is. See here, all the keys are sorted alphabetically, right? Start with B, C, C, D, U, W, right? Like, then we can do string comparison. Can do string comparison using this binary search we have looked at before. Right? We start from the middle and we compare is it smaller or bigger, right? If it's smaller, we go middle here again until we find a match. So this is the binary search do. All right, so now let's look at our, actually one more thing. When we declaring this structure, you could adding a secondary brace. So here you can see we only have one brace, like at the beginning and at the end. In between, there's no brace. However, supposedly you should have the secondary brace like this, because this is a pair, right? This is a substructure inside your array, right? This is each array member's value, right? You should have these things. But just because the compiler are very smart, they understand it, okay? Because you declare the structure this way, they will automatically break it out for you. So you don't have to add the additional brace on every pair of the structure. The other thing is when you declare this array, you don't have to give the row number, right, or the array size here. This is, again, very similar to what we have talked about array before, because you already initialize it with the amount of, say, 7 pair, right? You already did it, and then you don't have to explicitly provide the number 7, the size of 7 here. You don't have to do that. All right, so let's look at this program. Okay, again, the purpose of this program is to count keywords. Let's say you have a C code, and you want to scan this code and identify how many of those keywords we have seen has appeared. Right? Every time you find that keyword, you will increment it by 1. So let's look at our main function just to understand the basic logic here. So first of all, we will use a while loop to keep reading the content in our file. Well, in this case, we're actually reading from the input, but you can imagine if this is reading a file, the same idea. So this getword, well, every time you run it, it will give you the next word in your input. Okay, let's say you have a sentence with 3 words, so you keep running, and every time you use this getword, it will give you 1 word. All right. So you pass the word array into it, so to store this particular word, right? Also, the getword will return the type of it. Okay, this T means what's the type of the word is. Essentially, we want to differentiate the letter from numbers, right? Because sometimes you could have numbers inside, which we don't care. We don't actually count those numbers. So we ignore them only. We do that if the type is letter. That means the first character in a word is a letter, right? We keep doing this until we find end of file, right? This is this while loop do. And then if the type of the word we get is letter, right? This letter is our predefined variable. Well, essentially, this is just a character A, just a placeholder. But essentially, we kind of define as a letter. If this is a letter, then we need to find if this word is belonging to our key tab, which is the structure we looked at before, using the binary search. The n key here is how the number of key in our key tab. We'll talk about this a little bit later, but essentially the binary, what this binary search do is it will just comparing string by string, right, until you find this keyword, and then you return the position of this structure in your array, structure array, right? Then you increment the corresponding key count by 1. All right. Again, remember the structure is look like this, right? You have a pair of keyword as long as a count. Yeah, and then you will find the corresponding position of this keyword. For example, this will be my keyword. So I record the position of it is 2. And I will return this into this n here, and then I'm using n to increase this key count by 1. Okay, so let's say we're doing this while loop, and to finish everything have inputted. After that, we will go through this list again to print it out, essentially, right? We go through the entire list by number of key inside, and as long as the count number is bigger than 0, we'll print it out the count number as well as this the keyword itself. Right? That's the output part. Okay, so now let's look at this m key. Okay, so previously we talked about when we initialize this key tab, we don't have to decide what's the number of key here. That gives us the convenience because later on, let's say when you're making your program, later on you say, oh, actually I need to add 2 more keywords into this list. You can do that without changing this n key, right? But you still have to calculate it. So how to do that? So you can make a definition of the n key through a quick calculation. This calculation is size of key tab divided by size of the structure key, right? Because this key tab is an array, right? And the array size divided by the structure inside this array, you knowing how many entries of those structure are inside your array. So this is a dynamic way to calculate the number of keys without you to explicitly deciding that, just to make sure you don't make mistakes, right? Because once you start to change code, you often will leave some of those variables unchanged. It will cause some problem later on. So this gives you a dynamic way to calculate the n key automatically. Binary search. This one, not going to get too much detail, but the essential idea is you're comparing 2 things, right? While you're trying to find your word inside your table, keyword table, and you're finding the middle point, and you compare your word to the keyword in the middle point. If it's smaller, you go one way. If it's bigger, go the other way. If it's equal, you return itself, right? If it's nothing fine, you return -1 to show it's not in the list. Okay, so the most interesting part of this program is this getword. The idea here is our input will be a sentence which will be separated by space, for example, and we want to break them up by space, right? So in this particular example, we wanted to do is we will read. Okay, first we'll use the get character function. remember this get character function, we have a buffer, right? And we read everything first, and if we're going to unget it, we'll put it back to the buffer, right? So this expression is a little bit confusing. Let me break it up for you. Okay, so this particular expression, okay, what will be the first part in this expression? Anyone can tell me? What happened first? What's the first step in this expression? Any thoughts? No? All right, so the first part will be this part, okay? Get character, right? You get the character first, okay? Then what happened? The next operation is this one. Okay, what does that mean? So we have our pointer defined as a character pointer, right? So we'll assign the first character we got into this character pointer, right? This is almost a character array, right? You can store as many characters inside this array as needed. You store it into this position, then you increment this pointer by 1, so it's ready to accept the next character in the next round, right? So this is how you keep getting the character into this character array, right? And the third part of this operation is we also store the value of this character into this C. Okay, this is a little bit confusing because essentially this operation will happen first, right? You assign whatever information you get from the get character into this W, and the result of this the equation is the value on the right side. So essentially, if you're going to have another equal sign here on the left, you're assigning the value of this get character into this C now. Okay, so your get character value will be stored in both this character array as well as this C integer C. Okay, happen in the same time. And finally, we passed the value, we passed the entire value into this type function to determine if it's a letter or if it's a digit, okay, in this case. And then we compare the result of this type function. If it's not the letter, right, and then we'll just return it. Well, before we return it, we'll finish our character array by adding this terminator at the end, but then we would just return this this character directly. So this is one scenario. The other scenario is now we know if it won't be the letter anymore, right? Because it won't be the digit anymore because this already passed this condition. So if it is the letter, okay, if it is already, we know that's the letter, then we're going to keep getting more character, all right, as long as the type of the character is either letter or digit. Okay, we'll keep doing it until either of those, well, I would say actually neither of those works, right? So it's not letter or digit. It will stop there. But before we stop, we want to return the last character. So we'll use this get character to return it back to buffer, and we stop our while loop. The while loop will also stop once we reach our limit of our maximum size of the word. And finally, we're terminating this word array using this /n. Oh, sorry, /0 is a new terminator. Right, the reason we're using the -1 is because we have returned this non-letter, non-digit symbol back to the buffer, right? So we have to override that one as well, because our W pointer is already pointing at the next position. That's too much. We'll reverse the back to the previous location, and add the new terminator to it. All right, again, this will be the most confusing part of the function. You will have an exercise later on for this one. Okay, one last function is a type, right? We have looked at there's a type function will return either a letter or a digit. If it's not letter or digit, it will return the character itself. So, but hopefully you're already very familiar with this. So I'm not going to give too much detail. All right, so today we have 2 exercises. First of all, I want you to do is to modify this keyword counting program. We just look at it. Now we want to include a scenario that we will have our program ignore any input in between the double quote. Okay, the double quote, anything in between them will be ignored, not for counting as a keyword. Anything outside them is still be counting for a keyword. So let's see.